Hi, everyone. Welcome to our webinar on active antennas and X-band versus Ka-band dynamics. My name is Jack Coor. I'm the research director at Payload. We are joined by Nicola, the CEO of Anywaves, and Philippe, telemetry and command RF expert at Airbus Defense and Space. Maxime, who's the CTO of Anywaves, is sick today, so he's not going to be joining us, but very excited about this discussion. We're going to talk all things antennas and bands. We're going to try to make this a very interactive session. So please, if you have any questions, and I'll remind you throughout the webinar, but if you have any questions, just put them in the chat and I'll get to them, and we can kind of have just an open discussion as any thoughts arise. So with that, let's dive in. So we have Anywaves and Airbus Defense and Space. So first, Nicola from Anywaves, could you please introduce yourself and maybe what products you're bringing to the market, and just give an introduction of your company?
Yeah, sure. Hello, everyone. So I'm Nicolas Capet, the founder of Anywaves, and Anywaves, we are space antenna makers. Just to give you a brief introduction about myself and why we founded Anywaves, I was previously working for the French Space Agency in charge of innovation at antenna level. And we saw this revolution about the space markets with a lot of new projects with constellations of small satellites. And on that time, there were a lack of good products well suited for that kind of market. So this is why I decided to create the company and propose that new generation products well suited for the market. What we propose is antennas for these satellites with, I would say, three main points. First, small and high performance. Thanks to our expertise and the way we can manage qualification and harsh environment design at mechanical thermal level and obviously radio frequency level, we propose very good products with small form factors. What we do also is high quality products because we believe in a sustainable space, and also because antenna are key equipments at satellite level, sometimes without redundancy, so we cannot have a failure during the whole lifetime, the whole mission. So quality is extremely important, and this is why we put a lot of efforts on industrialization and keeping certification quality AS9100. And then the third point that is very important for us, and the way we think our products, is to be capable to produce a lot of antennas in very short delays. We are talking about hundreds, thousands antennas a year to address the market. Today, we have a product portfolio on TTNC, telemetry telecom of the satellite, also payload telemetry for data downlink of the payload data, and navigation antennas. All that kind of antenna, you can find it on every satellite, and our job is to propose an extremely good product with to address all our customer, the satellite manufacturer who wants a reliable products for their mission. So today we are focused definitely on satellite constellations because this market is really dynamic and there are a lot of projects. But in long term, we are going definitely to extend the type of space vehicles we are going to address, because we are pure space antenna makers. And we already have qualified an antenna for reusable launchers, but tomorrow there will be also space tugs, there will be also some rovers, and we are working in collaboration with the French Space Agency and the German one for a Martian rover, and tomorrow also all the lunar projects. And what we want to do is to propose a complete set of antennas who can address all this space mission and contributing to this space revolution.
Thank you, Nicola. And you and Philippe are both in Toulouse, France. right now, and Philippe, I'll give you an introduction as well. But your Anywaves business is international. Am I correct? It's French and
Yes,
international
definitely.
customers, U.S. customers.
Yeah, completely. We already have sold antenna all over the world, in Asia, in US, in Europe, obviously. I think this new space market is a global market, and what we want is to make our antenna technology accessible to everyone who has a good project in space, and being capable to deliver as many antennas as possible in a very simple way to all our customers. So anywhere you live, you can ask and we can deliver a good product.
Great. Thank you. And Philippe, I'll turn it over to you for an intro on yourself and Airbus.
Hello, everybody. My name is Philippe Allotti. I'm a telemetry and telecom RF expert for Airbus Defense and Space. So Airbus Defense and Space is part of the Airbus group, and it is the second largest space company in the world. And it develops, integrates, delivers satellite in flight for many customers, either commercial, defense, or science or institutional programs. For my personal objective today is I am working on R&T, and Airbus is working on the possibility to respond to the request in the market to deliver more and more data to download to the ground stations, and with different techniques. One could be the K-band, the other one could be higher order of modulation, and of course, active antennas. This is one of the main activity I'm focusing on, and to summarize is to respond to the request to export customer or institutional customer to increase the data throughput for payload science or imaging.
Great, thank you. So it's for Airbus, a lot of it is centered around increasing how to increase throughput data rates through kind of next gen technologies. I know you have a really interesting slide that if we could try to put up, I think that'd be very helpful to give the audience, kind of show the audience the dynamic of legacy antennas versus kind of new active antennas. There you go. Philippe, can you walk us through the slide?
Yes. To summarize, present the different type of antenna along the history, but they are still used. The first type is the isoflux antenna that can deliver a large coverage for data payload transmission, but this kind of antenna has a drawback to have low gain. So at the end, the data throughput is limited. So to increase the data rate, we can go to directive antennas like horn. The difficulty, the point with horn is, of course, you are directive, but the coverage is reduced. So you have to point the satellite for transmitting the data, and the drawback is that you cannot imaging in the same time, or you cannot do your science mission in the same time. So you cannot deliver real-time data when pointing the satellite for downloading. And so the other alternative, which is all these are implemented on satellites, are ongoing solutions, is to implement some steerable antennas. So we could imagine that we can steer the antenna to point to the ground station while the instrument is imaging or doing science. The main drawback of such mechanical steering solution is what we call micro vibrations. So in fact, depending on the mission, you are not allowed to transmit in the same time as imaging, but because when you are moving the antenna, there are vibration, and this perturbs the mission. That's why we are very big interest in the electronic active antennas. This is not a new solution, but with technology improvement, it is a very interesting solution because we can cover a coverage which is almost similar to the isoflux I showed you at the beginning. but with a capability with higher gain because it is a beam you are steering, and without the drawback of micro vibration. So it's a smooth, let's say, steering that allow to download the image while you are imaging or doing your science mission. So you can answer to one of the main requests of our customer is to the real-time downloading of the data. So that's why active antenna, we are focusing on them, and this is very, very interesting potential products.
Great, thank you. And we have, once again, everyone, if you want to ask questions, just put it in the Q&A box and we will certainly get to them. This was actually going to be my next question anyway, but the first question we have from an attendee are what are the advantages and drawbacks versus electronically steered active antennas? And I guess we see it, Philippe, from a customer and operator perspective. I think we could see why active antennas will be useful. But Nicola, maybe if you could take this one, what are some advantages and drawbacks of these antennas? What is Anywaves developing right now, and maybe what are the difficulties in this move or the demand for active antennas?
Sure. As it was told by Philippe, one main advantage is that you are able to move your beam and have very high throughput without moving the satellite, without vibrations, and avoiding mechanisms that are quite bulky, expensive, and with sometimes reliability issues, because moving mechanisms are quite difficult to develop for space. And definitely also it's important to get smaller and smaller antennas, especially for constellation markets, when you want to put as many satellites as possible in the launcher. So the fact that you are flat is very, very interesting. One big advantage too is in terms of reliability, because when you use active antennas, so you have one amplifier behind one radiating element, and controlling all these radiating elements, you are able to move your beam to focus on the ground station. In case you have a default during the lifetime due to radiation, due to whatever, it's a smooth degradation. So you will continue to perform your mission. Maybe you will have a little bit less data rate, data throughput, but it's not, okay, the mechanism have a problem, the mission died. So it's definitely one big advantage. Nevertheless, big advantage, sometimes some drawbacks. Drawbacks because first, it's a technical challenge to develop that kind of antenna, and being capable to steer the beam at very high elevation angle to be able to cover all the Earth at low Earth orbit. So we have to be very clever, very smart in the choice of the architecture of the antenna, in the way we design the antenna at radio frequency level to do that. Luckily for us, we have this expertise, so we know today that we can do that. One other drawback and challenge for us is the fact that such antennas have sometimes big electric consumption. And contrary, for example, to active antennas that are already used for telecom missions, we are not the payload. And when you design a satellite, you size, I would say, your solar panel, your batteries, etc., to be capable to operate your payload. And then you have only few amounts of energy, place, and thermal controls to dedicate to other equipments inside the satellite. And the big difference between payload telecom and active payload telecom antennas is that you can use most of the satellite energy, and you can definitely design your satellite to manage that kind of thermal equipment. But on our side, we have to be as discrete as possible at system level. It's a real challenge because we have to be low electrical consumption, low thermal dissipation, and obviously low cost as it is possible, at least extremely competitive with respect to all the payload aspects. But now, and that's why also I'm very happy to share this moment with all our auditors. It is that this technology is very interesting. Everyone wants that low cost, low consumption, and extremely efficient active antennas. But there is the reality, there is the technological barriers and the gaps we have to go through. And I think, at least based from our recent research development for active X-band telemetry antennas, we are ready to propose good products having both advantage to answer our customer needs.
Great, and that's you're developing these active antennas currently, and trying to perfect the technology. And Philippe, I want to, just because we touched on it, I want to talk about Airbus here. So Airbus has, if I'm not mistaken, Airbus has active antennas, but in GEO, and for bigger satellites and telecom specific applications. Can you just talk about the difference in, let's talk about imaging, EO, and where the payload is really the main mission is to take an image of a site in Earth, and how does that differ and make it more difficult to use active antennas on board?
Yes, for telecom, the difference is that the main difference with we are speaking about Earth observation, so means we have in altitude around 700 kilometers. So in fact, we have not the same need in terms of ERP, means power to transmit the bit. And the second thing is that as we are in LEO, the coverage needed for a mission is the largest, is the best. So in fact, 65, 70 degrees will be appreciated to have a steerable coverage. The difference for telecom is as we are in GEO, we can see the Earth within plus or minus 9 degrees coverage, so the steering is very low. So at the end, we have a very, very big antennas, let's say antenna arrays for telecom due to the ERP, which is very high. And but at the contrary, it's more easy in terms of steerability. These are the main differences between GEO. So today we have this kind of product, yes, but it's not adapted to the need in LEO.
Great, and we have a bunch of questions that I'll get to right now. Maybe we can try to keep it short with the answers because a lot of them are factual questions. But the first question is for active antennas, talking about directivity. The question was, is it about 20 dBi for the directivity? Do you know that answer, Nicola?
Yeah, definitely. It is I would say the minimum directivity we are going to address. Sometimes it can be higher. It's always a compromise between the power you put inside your antenna and the directivity at the antenna to at the end get the good IRP and the good data rates for your mission. But typically this range even a little bit higher. Yes.
I would add that the gain is one point, but the performance is directed by the what we call the EIRP, which is the gain plus the power, the RF power you have behind the antenna. So you can have a 20 dBi gain if the amplifier before or is very low. So you will have no interest. So we are speaking more in terms of ERP, which can lie for 30 dB watt to 50, depending on the application. For telecom, it's more 50, and for LEO, it may be 30 or 40. So depending on the size of the satellite and the objective of the mission. So what is important to understand is gain plus amplifier.
Right. And another question from the audience is what products, and I think this is referring to because we're talking about EO, LEO, smaller sats. What products are electronically steering products are and active antennas are available right now? Philippe, do you have maybe I'll toss this to you.
Yeah, actually, it's a quite difficult question to answer, because what we see is that today most of active antennas are dedicated to the payload mission. You can see that on telecom mission, Earth observation mission, all that kind of thing. So, and generally, yeah, companies like Airbus and other ones design their own payload antennas, because at the end, it's what can perform the mission. When you look at the data downlink for your mission, it's something completely different. It was presented by Philippe at the very beginning. I would say the state of the art is more directive antennas on mechanisms, on gimbals that are available. But from what we know, at least, we don't see such active antennas on the markets available to perform that kind of mission. It's another game, you know. When the payload one, you focus your design, your platform energy, etc., to perform that kind of mission. So you don't have the same architecture, you don't have the same constraints in terms of coverage, in terms of power, all that kind of things. But when we talk about data downlink, we have to be extremely efficient in terms of energy, thermal dissipation, and yeah, from what we know, there is still a need.
On that, on the low power consumption, how do you dissipate the heat? This was another question from the audience. Is there any comparison between electronic active antennas and mechanical with regard to power dissipation drawbacks?
Yeah, definitely. Because when you use mechanical antennas, so it's bulky, but you can use solid state amplifier that are more efficient in terms of energy compared to SSPA, the technology, the chipset technology you can use in active antennas. So definitely we have to take into account in our design how we are going to evacuate and manage all the calories dissipated by such technologies. We are highly dependent on the chipset technology, obviously, and their efficiency at the end. And the way we are going to maintain a good thermal compensation inside the antenna, and I would say not interfering or disturbing the global satellite thermal management, so having our own way to evacuate the calories in space in order to maintain a good temperature at antenna level.
Great, and so Airbus is looking for the next generation satellites to incorporate active antennas, and I think this is also a good way of bringing in X-band versus K-band. And if we can, Philippe, maybe I'll toss this one to you. If we could just discuss define X-band versus K-band, and if Airbus and maybe broader European space operators are looking to move in one direction or the other.
Good question. Okay, so in fact, to summarize, the payload data transmission is authorized by ITU to be transmitted in two bands today, or X-band or K-band. And most of the current mission or past mission were using X-band. Now K-band is coming, and more programs are using it. But today, for Airbus, these are more institutional programs. The main interest between X-band and K-band is that we have 4 times the more bandwidth than in X-band. So we can throughput more than 4 times, even 5 times that we could do in X-band. Just to give you an example, I did a calculation. Let's say you can image the France with a good resolution and download the image in K-band in 2 passes of 10 minutes. Means if you take into account the orbit, for one station, it will take less than 2 hours. If you could do the same thing in X-band, it will take half a day. So the interest of X-band is in this direction. It is the only way if we want to provide more and more data to the ground. There is no other way. Even if X-band is answering many programs today. But if the demand in terms of customer is or mission, science mission, please, it is asked to deliver more and more. We have mission for science, let's say today, which can offer up to 8 gigabit per second compared to X-band, which is 1 gigabit maximum. So it is obvious. The difference between X-band and K-band is the capability to offer more data, transmit more data to the customer upon his requests. This is there are other advantages in terms of dimensioning. The difficulty of X-band to be near to the D-space band, so we have to implement art filtering to avoid emission in this band. So there are some, of course, there are drawbacks in K-band, but the advantage for K-band are this one. It's more room and to deliver to the customer.
And anyways, Nicolas, I'll let you kind of respond to that on your opinion on K-band versus X-band and how that factors into your business.
Yeah, as it was told by Philip, the more we are developing the space technology, the space mission, the more we will need data. We all know that. We saw that on ground. It will happen in space, no doubt. The thing is that from a technological point of view, it's not as simple as that. Today, K-band is definitely more complex than X-band at technological point of view. Obviously at radiating element parts, but also, and especially for data downlink antennas, active data downlink antennas, at the components we can use, and this aspect of efficiency and thermal management with respect to the electrical consumption, because today most of these missions are done with small satellites, and small satellites are limited in terms of energy, onboard energy, but also are more complex to manage in terms of thermal issues. So the question is not, do we need it? Do we want it? The answer is yes. But the question is, when is going to be the good time to market, and I would say the good match between the needs and the products we can propose. Also in terms of price, obviously, X-band is not the same price than K-band. So today we are convinced that we will go to K-band active antenna standard products, but what we think is that as a first step, and because most of mission in LEO constellation are using and are quite happy with X-band, is to first develop a standard antenna for data downlink in X-band. We hope being capable to propose that product in, I would say, 18-24 months, something like that, in order to address this constellation market. And then after that, obviously, the time will come to develop a K-band standard product to answer that kind of need, and the increase of data downlink we want for our customer.
Great. And just to summarize, and we could summarize kind of the active antenna conversation too, the from the operator, the Airbus perspective, there's a clear demand and need and want to eventually go to active antenna and active antennas in Ka band. And from the manufacturing standpoint, Anywaves are building a X-band active antenna that's in development, and will come out in the next 18 to 24 months, and then you'll move to address the Ka band market too. But it's a very, very difficult technological. There's a lot of technological problems, or I should say challenges, to getting there. But that's something that you are working on. And I think and there'll be there's another question. I like this question from the audience on what differentiates what differentiates Anywaves as a antenna manufacturer, particularly in this active antenna space, and that's compared to maybe competitors.
Actually, there are some other antenna players that are doing active antennas, but they do that for the payloads. And as we discussed, we are not playing the same game. The payload can be extremely complex with a lot of beams, active beams, multiple directions, being, I would say, fed with a lot of energy, and the full mission is designed around that kind of active antenna. This is not our game. Our game is to propose, I would say, and it can be to that kind of payload, in addition to that kind of payload, a very simple, cost-effective, and efficient product to bring your data on ground. So we are not on the payload side compared to a lot of other players, but we focus on the way we can serve all the satellite manufacturers for Earth observation, for telecom, for science, for everything, to bring at the most efficient costs on ground, and to, I would say, being capable to use their satellites even while downloading their data at the most efficient cost. So this is what we focus on.
Great, thank you. And Philippe, a question for you in terms of cybersecurity. And this is a big discussion that we're having, and particularly when it relates to national security, birds and payloads. The question is, where do you see the most critical component of your antenna tech that is vulnerable to a threat? And Nicola, you can answer this as well, but maybe in general, how do you look at cybersecurity when deciding what bands or antenna tech you're using?
Say, okay, maybe I will give the floor to Nicola, but from my point of view, it's we are speaking about mission which are downloading to means a link between the satellite and the ground. So cyber security equation, and we have to identify what could be the threat. Today, in addition, we are speaking about the focus would be commercial application. We are not speaking today, but maybe tomorrow, of military application. But we have not dimensioned our system to be, let's say, to avoid any threat. So in fact, I don't know what could be the answer in terms of technology, but the system is not identified with respect to cyber security.
The thing is that at antenna level, we are working in very low level of layers. We are not in applicative level. So what we do is whatever the signal, whatever is inside, transfer the data at radio frequency level. Cyber threats are more at applicative level. So you can enter a system, but at higher level. We are in the pure hardware, and so and it can be used to protect the system. But I would say our threats is more at electronic level, electromagnetic jamming, all that kind of things. It's more a threat for us when we are doing that kind of radio frequency hardware. But at cyber level, it's more at system level, etc., etc. It's not a threat actually for us.
As I said, we are imaging, so depending if we are for commercial application like Google, don't see it as to protect the link. Okay, so at the end, when you ask a question like this, please identify which kind of threat you have to face.
Right. Okay. And then maybe we could talk about ground stations, ground systems. How do active antennas and potentially move into K-band impact the ground terminals?
Definitely, where it's also one advantage of X-band currently. It is that you have a ground segment that is already available to perform the mission. K-band is I would say more recent. Still have to develop a new ground segment, also to have a lot of point of contacts. Also in terms of price, K-band is more expensive than X-band because you need a lot more precise technology. All the amplifiers, etc., are also more expensive. So both ground and space segments have to evolve at the same time in order to get market reality and to make it as simple as possible for the customer to use one or the other of them. And this is also why we are convinced that, X-band is the good time. There is the need for that kind of technology for downloading the data in a more efficient way. And step by step, K-band will develop, will evolve, and it will come the good time to move to K-band.
Great, thank you. And then maybe a technical question here. What is the maximum angular sweep range of the antenna? And what is the beam width at the max sweep angle versus broadside?
I would say the order of magnitude is plus minus 60, 65 degrees. And when, we are on that kind of angular domain, main beam, the 3 dB beam is around maybe 10, 15 degrees.
Okay, great. And Philippe, maybe let's fast forward 5 to 10 years. How do you envision the role of active antennas maybe changing in the next decade? Do you see all of your satellites moving in that direction? And particularly, how is that evolving with the growth of smaller satellite constellations?
So yes, as I said at the beginning, the K-band is a way to increase the data throughput, and there are some other advantage in terms of more let's say complex missions, and yes, K-band, we can see for institutional programs, it has most of them are today in K-band, means for European missions. So for me, my point of view, it's a very personal point of view, will go to K-band in any case. So the second point is more difficult is to see how this kind of technology and K-band will be implemented on small satellites or constellations. I'm still speaking about the mission of downloading data, and not payload, telecom payload. Today, we said, X-band is enough, but tomorrow it cannot be enough. And with the possibility to have many for example, many stations on ground to be able, for example, the active antenna it will be possible to have multi-beam antennas, means to connect different users in the same time. So for me, the roadmap is to go. If we want to increase and to have the higher data rate, we have to go to K-band, even if it is for a small satellite or constellation.
Right.
X-band will be always here, but more and more crowded and limited in terms of data throughput. The maximum we can do, I don't know if it has a sense for people who are all in the webinar, but 1 gigabit per channel is a very high limit, around the very high limit of the X-band.
Yeah. And historically, France has been pushing X-band. Is that correct?
There are no other solution because ITU regulation define where the application of payload data transmission can only be done or authorized in X-band, means between 8 and 8.4, let's say, or in K-band, between 25.5 and 27. That's all. You cannot do the same function in other bands today.
Yeah.
It's an equation on Q-band. Yeah. We are investigating the possibility also tomorrow to go, or to the day after, to Q-band. Yes, we are work on it, and we have defined that it's not, we are not so far to be able to do it. The main point is the regulation once again, where the payload data transmission is a secondary, it's not primary, so we may face interferences. So we hope it will be discussed in the next ITU conference, the possibility to open this band to the PDT. Yeah, but it's not the day after.
Great. And then this one is for Anywaves, another question from the audience. And appreciate all these questions. It's really I've done a lot of these webinars, and this is a very interactive one, which I love. I love to see the audience participation, and apologize, we're definitely not going to be able to get through all of these, but I think this is a very helpful way to guide this webinar. But this is another question that came in. At which stage of Anywaves, Nicola, of your roadmap are you guys in today for the X-band product you talked about? You talked about that 18 to 24 month kind of timeline, but can you just talk about that development process?
Yeah, just to give more insight about what we are doing at this level. So we already have worked on and in collaboration with Airbus and with respect to their needs for Earth observation missions. We have worked in R&D to define what is the good antenna architecture. We have to select are all the technology components available on the market with the good performance in terms of efficiency. What also is the target price on which we should focus on in order to be competitive to other and traditional solutions. And at the end, what is the number of antennas we can be able to manufacture? Because when the technology is complex, sometimes it's very difficult to produce a lot of equipments. So step by step, we have studied, we have found solutions on each of these points, and now we know that we have to do that. So it's, would say, classical development we are going to go through at antenna, going to the critical design, to the qualification, but all the main technical, industrial and manufacturing risk has been addressed. So now we have to do that. It obviously takes time because developing a good product and highly reliable and being capable to produce it at the end with a volume adapted to the constellation market is a lot of investment. This is why it will take some time to propose and finish the industrialization of that product, but we are very confident that this product is going to be available and be very relevant for the market and our customers.
Yeah, great. And there's a couple questions about price, and we're not going to get into specifics about price because the product hasn't been made, but I think it's clear that the price is going to be higher for the customers to some degree than traditional products. And maybe, Philippe, if you can kind of talk about the importance of this next gen antenna product, and if your team would be willing to pay more for it, and how do you manage price versus performance?
Difficult questions. Yeah. Today, it depends on the mission, and if we are speaking about commercial, means export mission, or with imaging or science mission. If for mission which are not sensitive to the micro vibration, etc., so we can use a steerable, mechanical steerable antenna. We cannot see main difference is the price is not lower. For commercial mission, we have no other way to use this kind of antenna, because at the end, if we have a similar price to the actual solution, this could be a good point, because at the end, it is not the price of the antenna which is important, it's the price of the bit. You have the antenna, you have the accommodation, you have the ground station, you have the volume of data you can transmit. So it's a global evaluation. But of course, if an active antenna is as a cost which is the optimum will be a similar cost to the steerable, mechanical steerable antenna. This will be a compromise. But right. Of course, if you want to implement this kind of antenna on CubeSat or microsat, it may be too high. So from my point of view, I don't know if it will be shared by Anywaves. We may have different products depending on the application and technology, using components which are compatible with a microsat or small sat, and other ones that are compatible with, let's say, institutional missions.
Yeah, definitely, I agree. And this is why also we develop our first X-band products for data telemetry, more dedicated to our current market, with very small satellites in constellation that cannot afford, even at energy or space available on the satellite, they cannot afford such active antennas. So we have a specific product to address that need. Obviously, it's a lot of it's more competitive compared to active antennas, but it answers the need. And also because small satellites don't have the same need in terms of data they can have to bring on the ground. And there is the future constellation, and we see that more and more small satellites are going bigger and bigger. Very big satellites are going smaller and smaller. And so this is why we are convinced that such products are going to be extremely well fitted to that kind of market perspective. Because if we can compete with traditional and bulky mechanical steered antennas, providing a lot of flexibility to our customer in terms of data rate, and at the end being capable to bring more data on the ground, which is the core value of the mission of our customer, we will find a good way to improve all our space capabilities altogether.
Yeah, Philippe, I like the way you phrased it, with saying it's about the data you bring down, and you have to kind of look holistically of the price and cost of the mission. Another question we had was on just your product set now, Anywaves product set that you have now. Do you have any products that are suitable for CubeSats of 1U, 3U payloads?
Actually, it's even more. I would say, yeah, our current products fits in one U surface and are very thin. But what we've done also, we use and we have customers who use it. It's the case for Airbus, but it's also, for example, the case for Maxar, for OHB. They use it on microsats because the way we develop our products is very high reliability, very high qualification level, very long lifetime, being capable to manage power inside. So we address a lot more than only the very small CubeSats. We definitely address the real constellation missions with our customer who needs to get their satellite as long as possible performing the mission to get their business plan okay. And yeah, it's a lot more than that. And we are even qualifying our current products for some geostationary missions, because they are extremely robust and reliable. But when we are talking about active antennas, definitely it will be, I don't know exactly, maybe 50 kilo, 100 kilo, starting from that kind of satellite category. Obviously depends our customer technology at satellite level, number of solar panels and what they are using in it. But yeah, it won't be for 3U satellites, sure.
A big topic of conversation in the space industry is implementing laser links, laser communication, and I think it's different from what your core products are. But what are the advantages of using X band or K band antennas versus comm links and optical links that we're hearing about?
Maybe to have a very simple answer, but I will let Philippe to complete. One advantage is that when you have a cloud, you can get your data. In optics, if you have a cloud or an object or whatever, the link is over. So in terms of availability, it's completely different. Even if there is a lot of data rates using optics, in terms of complete mission implementation, due to the atmosphere, it's a lot more difficult. And also all the performance at satellite level in terms of pointing accuracy, etc., etc. So it's a lot more expensive also to do that.
Yes, I completely agree. It's a point, and the only way is to multiply the number of stations around the world to be able to if you have a cloud somewhere, you can download in another place. But in that case, it's increased the number of stations. And the second point, as far as I know, I'm not a specialist in optics, but this solution is not yet implementing, and we are not close to have it implemented. So for the time being, yes, X-band and K-band, and perhaps tomorrow could make the gap to transmit a very high data rate. And we'll see in the future, but today it is the only way to I can see is to go to K-band if we want to improve our data throughput and the cost of the bits.
Great. And then maybe we have 5 more minutes left of this webinar, which has been awesome. Appreciate you guys doing this. I think we got really deep into a lot of technical aspects of it and whatnot. Maybe taking a step back, if we do get to a world where we have better data throughput, which is what Airbus and Philippe is really looking for, how does that change generally the future of space missions? Do you see how does that impact the space economy? How does that impact the need for data? Do you think that would lead to more satellites in orbit, or do you think that more data throughput might be able to solve the issues that we have in terms of imaging and EO, and maybe lead to less satellites, or less demand for more satellites in orbit?
So yeah, there's also several interests of K-band, and of course I said to increase the data throughput, the cost of the bit, the number of stations, And we can see that we are more in the communication and transmission of many data. It is in the way of the future. I don't think it will reduce the number of satellites, but it allows, as I said, increase to have better quality and to have larger missions, which is the essence of the space.
Right. Yeah, I completely agree. And what we see in space is that we are able to collect more and more data which are extremely useful for many new application, new use of this data, and now space is at the end data economy. And the more we are going to be efficient in terms of price to get data, the more we will be able to propose competitive services that are going to be used more and more by more people. So I'm definitely convinced that bringing such technology to the market will also boost the way we are going to design, use our satellite, and provide additional services, more efficient services, and to use space for many ground applications at the end.
Mm-hmm. And I would add that what is the future also maybe is the connectivity and the inter-system connectivity. And in the future, we may think to inter-satellite link in Cuba, one satellite communicating data to another one for transmission. So we are more in this, let's say, scope than reducing the number of satellites. More the connectivity is the possibility to have access to the data in real time everywhere on the world. So we are more in this kind of application. And the active antenna may be a solution for K-band, for payload data transmission, but also for inter-satellite link.
Great. So we have the webinar is coming to an end now. Anyways, Nikolai, do you have is there any way we can communicate? I think you have a slide that we can put up where we have a ton of questions, and if you want to reach out to Anywaves for these kind of technical questions, I'm sure they would welcome that. I know there's a lot of questions in the text box, in the question box that we didn't get to. There's also Philippe's email address is at the bottom there as well. So you could take that QR code or just reach out to either one of them. I'm sure they would love to talk. But this has been awesome, guys. This is really appreciate this. I think it's been a really fruitful discussion and interesting conversation. And very interactive, to say the least. So appreciate both of you guys joining.
All right. Thank you, and thank you everyone for contributing all these questions. Don't hesitate to contact us, and see you soon with our products.
Same for me. Thank you.
Thank you.